Now let us look at the next example for thermal stresses. We have a cylindrical rod assembly of 4 cylinders connected end to end, has frictionless support applied on all the cylindrical surfaces, and both the flat end faces are fixed, as you can see over here in the image. Thermal and structural loads are shown below. So you can see all the loads that are acting on the body, thermal plus the structural loads. We can also see the dimension properties of the rods, and the material information is also given over here. Okay. Apart from the other loading conditions, we also have a remote force location over here. Okay, now the remote force acting on the body, the location has been given as 7, 0, 0. That means in x, it is at a distance of 7. Now, if you also create the model in the same orientation, you can use this coordinate system. But if you have changed the orientation of the model, you will have to change this location also. So please understand the orientation. You can see how the beam has been oriented, the assembly has been oriented, and you can perform it. Okay. Now, if you feel that you can perform this in 1D, please don't use the 1D method, because there are some supports like the frictionless support that has to be applied. It can only be applied on surfaces. Please understand, frictionless support can only be applied on surfaces. So if you take this problem to be a 1D problem, you will not be able to give this support. Okay. So let us perform this analysis. We will come to Ansys Workbench, and in this case, what we are going to do is we will add one thermal stress system from the custom systems. When you do this, you will get both the systems simultaneously over here. The material that has to be used is structural steel, so I don't need to enter over here. I will directly come into the geometry. Okay. Set your unit system, it is into meters, and now start sketching. So I'll take the XY plane and I will start creating my sketches. Now please remember, it is an assembly that we need to create. So this first one is of 2 meters. You can see the dimensions over here, 2, 5, 10 and 3 from this end. Okay. So I will say this is 2 meters. We'll keep it at a distance of total is 2 plus 5 is 7, 17 and 3, 20. So this should be 18. Just 2 and this is 18. Okay. We will come to the modeling part. Now we will add extrude material to this. And what we can do is we can create, instead of extrude, we will use the sweep option. For that, I'm going to create a plane. Shift the YZ plane, and the offset direction is -18. Okay, generate. I'll take this plane 4, sketching. We will make one circle whose diameter is 2 meters. Show, and this also has to be always shown. Okay. Now I will use sweep. The profile is this, and the path is this. Now from here I can directly select the faces. So select this face and enter into sketching. Then I'll make a circle over here whose dimension is 2 meters, and this has to be extruded up to a depth of 5 meters, but it has to be add frozen so that it is an SME. Next, I'm going to select this face over here and we will enter into sketching. I will say again, this is a circle. Depth is 10 meters. Add frozen. And finally, space sketching. The last depth is 3 meters. And again, this has to be add frozen, generate. So with this, we have the 4 bodies that are ready. Okay. Now let us take this into the mechanical window. Okay, so the bodies are created. All the 4 bodies have the same material, so I don't need to change the material. We have contacts. By default, all the contacts will be bonded. Let us mesh the model. We will get the default mesh settings, and the default mesh will be generated. You can see them. Now let us apply the first thermal loads. So according to the thermal loads, we have only temperatures applied on this end and this end, that is of 1000 degrees Celsius. So I can directly select temperature, select this face and select the opposite face, and on both the faces I have the same temperature getting applied. Okay, apart from this, there is no thermal load, so we can directly solve this. In this case, we will not get any temperature. You can see this. You will not see any temperature distribution because it is only one temperature acting from this end to this end. Okay, so there is no temperature distribution. Now let us select the static structural node, and we will start giving the structural loads. So the first structural load that we have to give is fixed support at both these ends. Okay, then after this they have mentioned that there is a frictionless support at all the surfaces in between. Okay, we have to give a frictionless support on all the cylindrical faces, right? So I need to select this, all the cylindrical faces. Frictionless support has been applied over there. Then there is a remote force acting at a location of 700. So let us come to that. We will add one remote force. Once the remote force is added, select the geometry where it has to get applied. Then give the coordinates. So it has to act. It has to act on this, and the location is there. Value is 1 e raised to 10 Newton, and the direction should be in the opposite direction, right? So now we have the location. Next, we have to add the total deformation and the stresses induced in the model. Now let us solve this. So we can see the equivalent stress that is generated. You can see it in megapascals. It is 2260.2 megapascals. The deformation is 43.18. So the deformations and the stresses are quite high in this model because of the thermal plus the structural boundary conditions. So here we have seen how to perform a thermal stress analysis where both the loads are acting. We have thermal loads plus the structural loads that are acting. Okay.